It's back. It's here. It's Molly's Maths. It's the 8th of January. And here we go for some more exciting maths. Let's get the music on, get ourselves settled, and let's get ready for some real maths today. Without further ado, let's move on to question one. Ooh. Question one. What is 0.4 as a fraction? So we've got to turn a decimal into a fraction. How are we going to do that? So what we need to do is write it down. So we've got 0.4 equals, as a fraction, it's basically 4 over 10. But we can do more than that. We can simplify that. So how many 2's in 4? 2 2's in 4. How many 2's in 5? How many 2's in 10? 5. So there you are. The answer is 2 over 5. As I say, you could practice at home fractions, converting to decimals, and simplification is another good thing to do, just to get them in the smallest form. Let's move on to question 2. Question 2. Ooh, this is a graph with some coordinates on it. So basically, the question is, complete the parallelogram A, B, C, D. Write down the coordinates for D. Well, we've already got A, B, and C on there as part of a parallelogram. Parallelogram, I can't pronounce it very well, is a four-sided shape. It's a bit like a square pushed over onto the side, but I'm going to draw in what we have already. So you can see we've got two sides of it, and we need to put another point in there to make it up to complete the shape. So the coordinates of, we've already got a coordinates of A. I'll write the coordinates down here of A. Might help. So A, we've got naught at the bottom and 3. B is 3 along the bottom and 3 along the side. And C is 4 along the bottom and 1 up. Let's just write that one down as well. So they're the coordinates we've got. We've got to put one more coordinate in for D to finish this and to complete the shape. So I reckon if we put a coordinate there and we draw the line down, that looks like the parallelogram that we want. So that would be D. So the coordinate would be 1, 1 along and 1 up. So the answer for this one would be 1, 1. So there you go, you've got all the coordinates of A, B and C, and we put the answer in for D. I'm going to make this pen a bit smaller because it's a bit on the thick side. I hope you can read that. As I say, sometimes the graphs are quite complicated and easy to look, not easy to look at for some students. Let's move on to question 3. Right, question 3. This question says we need to increase 40 miles by 43%. Well, we're going to start off, the way I look at these questions is I like to say 100% for this question equals 40 miles. That's 100%. So 1% equals 0.4 miles. What we want is 100 we want 140%, don't we? We want 143%. So how do we get that? That would equal 0.4 times 143. And if you do that, on your calculator, the answer will be 57.2. Now, is that the final answer? We need to know what the units are, don't we? If we want to get those extra marks in the exam, and that will be miles. So these are the steps that I like to use. I like to find out what 1% is. And then once you've got 1%, you can do anything. You can find out whatever. You can find out what 10% is, 143% in this case, or any percentage you want. So once you've got this 1%, you're away. You can answer any sort of percent questions then. I hope that helps. It's not the only way to do this question, but it's the way I like to do it. How's the music going? Sounding good? Well, let's move on to the next question. See if the music's going to keep us in a good place. Oh, what have we got here? Oh, right, we've got a diagram here, a 3D object. This could prove a bit challenging. It's a 3D object, and it's a prism, which is in all effects. I mean, if you've ever eaten one of these chocolate bars, a Toblerone, it looks a bit like a Toblerone. So it's got like, it's a triangle, an elongated triangle. So what you've got to do here is we want to find out the volume of the triangle. I've sort of given you the formula here. The volume equals half the base times the height times the length. And on the diagram, we've got all the information on there. So what we'll do is, if I write this down, the volume here, V equals half the base is 5 centimeters, times the height it's shown on here is 4, and the length, it's 12 centimeters long. So we just put that into our formula, like so, and then we calculate it out. And has anybody got a calculator with them to do this? So we can break it down. So So we got 5 times 4 is 20. 5 times 4 is 20, and times 12 is 240. So if I write down 240, that's the bit in the brackets. Well, we want half of 240. And what's half of 240? The answer would be 120. Right. Is that the final answer? It sounds like it could be, but I mean, let's not finish up quite so yet, because we haven't put the units on there, have we? And when you've got so it's centimeters, and because it's volume, it's centimeters cubed. So there you go. Once again, there's a prism there, but if we go through the steps, we've got the formula, we go through the steps, we can get to the answer. So it's, I hope you find that's not too difficult to follow, and I hope it's helpful in answering the questions. Let's move on to the next question. Right, the final question. Question 5. It's the probability of winning a game is 0 to 3. I mean, I suppose lots of you guys have been playing lots of games over Christmas. You like to win, so the probability of winning is 0.3. So it's basically out of 1, 0.3 is 30% chance of winning. So Jane, she plays 200 games, or plays the game 200 times. How many times should she lose the game? Well, let's have a look at this. So basically, the probability of winning is 0.3. So we put win, chance, I'm calling it chance here, equals 0.3. So lose chance would be the opposite of that. .7. So it's 0.7 for one game. She's playing 200 games. So how many games should she lose? So basically, the question, so how you work that out is it'll be 200 times 0.7, because that's the lose chance of one game. And what does that equal? Anybody got a calculator? The answer is 140. And again, we need 140 what? And in this case, games. So Jane, who played this game 200 times, is probably going to lose 140 times. That's the probability of that she's going to lose. There's quite a lot of loses. I hope she enjoys the game, and I hope you're enjoying the music. Well, that brings us to the end of another Molly's Maths. Once again, can you update me on what music you've been listening to? I mean, has it been some Christmas ones? It's, you know, I'd like to know how it works, if it helps with the maths, the music, because, I mean, you get the right music on, and it puts you in the right frame of mind for some lovely maths. Anyway, that's it for this session. We'll be back soon, and it's a goodbye from me.